will discuss here horizontal stretch and compression. Suppose that the graph of the function g of x is given, and we want the graph of the function f of x, which is defined as g of c times x, with c being positive number. How are the graph of g of x and g of c times x related? Suppose that the point AB is on the graph of g of x, that means B is g of a. If x is equal a, then the g of c of x, or the value y corresponding to that x value, is g of c times a. I don't know much about the function g. I don't know whether CA is in the domain. I don't know whether that y exists. So I can't use this point to plot in the coordinate system. However, if I consider the point value of x equal 1 over c times a, then the value of y is going to be g of c times x, which is 1 over c times a. This becomes g of a, and g of a is equal b. Therefore, we can say that if point A and B is on the graph of the function g of x, then the point 1 over c times a, comma, b is on the graph of the function g of c times x. How are those points related? Notice that the y-coordinate is the same in those 2 points. The x-coordinate changes. And how the x-coordinate changes? If c is greater than 1, then 1 over c is less than 1, and therefore the expression 1 over c times a is going to be less than a. The value of a is divided by c. The value of a x coordinate decreases. So the graph is going to be compressed horizontally because y coordinate stays the same. If c is between 0 and 1, that 1 over c is greater than 1, and therefore this will increase the x coordinate, and therefore the transformation that will result will be horizontal stretch. Again, it's horizontal stretch because the y coordinate stays the same, but x coordinates are increased. So if I look at the graph in the example, the graph of function g of x that is given, and I want the graph of f of x equal g of 2x, this means that c here is equal to. And if I'm looking for the points on the graph, then I can say if I have a graph of g of x and the point on that graph is a, b, then the point on the graph of the function g of 2x is going to be 1/2 of a and b. Y coordinate doesn't change, the x coordinate is divided by 2. So for example, if I take the point -8 and 0 on the graph of g of x, then I will obtain the point 1/2 of -8, 0, which is -4, 0. If I take a point, let's say -6 and 3, the point on the graph of the function g of 2x is going to be 1/2 times -6, 3, which is -3, 3. If we do that to all the characteristic points of the graph, I can say that point -8, 0 will be transformed to the point -4, 0. Point -6, 3 is going to be transformed to the point -3, 3. Point -4, 0 is going to be transformed to the point -2, 0. Point -2, -3 will be transformed to -1, -3. Point 0, 0 will be transformed to 0, 0. Point 2 and 3 is going to be transformed to 1 and 3. Point 4 and 0 will be transformed to 2 and 0. 0.6 and -3 will be transformed to 3 and -3, and 0.8 and 0 will be transformed to 4 and 0. And the graph of that function will take on the following shape. This is the graph of g of 2x. As you can see, this is the black graph that is stretched, which is compressed toward the y-axis. That's why when the constant next to x is greater than 1, we'll have horizontal compression.